Hello and welcome to another video. In this video, we're going to be working on maximize the number of target nodes after connecting trees 1. And so in this one, you have two trees with distinct labels in the ranges of 0 to n minus 1 and 0 to n minus 1. And you're given two 2D integer arrays, edges 1 and edges 2. And so this is basically like the edges to build the trees. And then you're also given an integer k. And this problem's kind of weird to figure out what exactly they're asking, but essentially they're saying node 2's target to node v if on the number of edges from u to v, it's less than or equal to k, and the node is always target to itself. So like, let's take a look at that example. Let's say k equals 2 here. And let's just take a look at one tree at a time. So if we're at like this node, basically what they're saying is like every edge or every node that's 2 or less edges away is target to this node. So the node's always target to itself because it's 0 edges away. So this is 1 edge away, so that's target. This is 1, this is 2, this is 1, and this is 2. So for like this 0 node, all of these would be target and also these 2. Okay. And yeah, so then you're given this thing and then you're asked for every node in the first tree, you can make one edge from that node to any other node in tree 2 and then return the number of target nodes from tree 2 to the tree 1. Actually, from tree 1 to tree 1 and tree 2 to tree 1. So let's kind of walk through that because it's kind of confusing. So here's the two trees you build with the edges. And so basically they're saying like for this node, let's say you're allowed to make an edge from this node to any node here. And once you do, then you want to count the target node. So if I make this, so first of all, for this node, let's just go over one part by itself. So for tree 1, connecting it to tree 2 isn't going to change the number of target nodes for that one node. So this node, whatever the target nodes are in this tree, making this connection isn't going to affect that. So like for this, every node is a target node with k equals 2 in this case, right? Because this is 1 away, 2 away, 2 away, 1 away. So here there's already 5 nodes that are there. Now if I make this, now this is 1 away, 2 away, 2 away, and 2 away. So I added 4 more. So that's how I get 9. And then going to edge 1. So how many target nodes are there? 1. This one is as well. So this one, and this one. That's it. So there's 3 already. And then they're saying you can connect it to node 0 like this. So how many do we add? Well, we add 1, 2, 3, 4. So there's 7. So there's kind of like a few parts of this problem, I guess. Let's break those down. And also notice the edges are, there's only 1,000 nodes in each tree, so you can have like an n-squared solution. So let's just get rid of, honestly, most of this. And let's just keep this example. So there's kind of like a few parts. Part 1, counting up target nodes in tree 1, right? So counting up target nodes in tree 1. So like I said, like given a node, if I want to know the target nodes in the original tree, making connections doesn't matter. So this is like a separate process. How do I do that? Well, I can just BFS from that node to all nodes at most k distance away. So you could do this for every node, and that would be n-squared. So like essentially you'd be like, okay, I'll start here. I'm gonna BFS at most 2. So here's 1, 1, 1, and this is 2, and that would give me everything. And if I start here, then I'd get 1, and then these 2 are 2 away, and that would give me everything, and so on. So you can do a BFS, and that's gonna give you that. That's gonna give you the yeah, basically it's going to give you the target nodes for node I in tree 1. So that's the first part. Then you're being basically asked like, okay, well, what connection should I make from that node in tree 1 to tree 2? And then how do I calculate the rest? So notice like we can kind of do the same thing in tree 2. We can calculate for every node, like what are the target nodes, but there's going to be one small difference here. Like here we're going k distance away, but here we actually want to do the same thing. So do the same for tree 2, but BFS to all nodes k minus 1 distance away. So why is that? Well, because we have to make one additional edge, right? Like we want to know for a node we're connecting here to one in here, we have to make one edge. So how many more can we traverse to? K minus 1. So like if k is 2, from this, if I do 2, I'd get like this, 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 and this. But I can't traverse 2. I can only traverse 1 because I need this one extra one. So let's just do that. Right, like let's get these numbers. So here there is, for this node, there is 1, 2, 3. This is k equals 2, so this is 3. This is the whole tree. This is the whole tree. This is 1, 2, 3. And this is 1, 2, 3, 4. And let's do the same here, but here we're going to do k minus 1. So you can only go one distance. So here is going to be 2, 2, 4, 2, 4, 3, 2. And so notice for all of these nodes on the left, like this is how many connections we're going to get if we make this. This is how many more we'll make, right? Just BFS from each one of these to k minus 1. So we're always going to want to just connect to the one that gives you the most. So I think in the first example, they connected some nodes with this and some nodes with this. And that's because these two give you the most. So it doesn't really matter which one I can connect to. I can always just pick the biggest. And so I can basically say like, okay, for every node in here, just give me the biggest one. And I can calculate this biggest one. Like once I get this, I'll just take the biggest value in this result array. So let's do that. It's going to be part 3. Get biggest value in part 3. And then the last part is just for every value in part 1, add, or this is going to be part 2. Add value from part 3. So essentially the biggest value here is going to be 4. And we can just say like, okay, so for each one of those, we know that's what we're connecting it to. So that's going to be our best. So it's going to be 9, 9, 7, 8, and 7. And that is the answer, I think. Like if we go to this thing, 9, 7, 9, 8, 8. Right? So 9, 7, 9, 8. For some reason, for the 4, was the 4 8? Let's see. 8, 8. Yeah, so maybe I did something wrong here. Let's see. Oh, this should not be a 3. This should be a 4, right? Because if this is 1, 2, 3, 4. Yeah, okay, so that was just a mistake there. So this shouldn't have been 3. This should have been, whoops. This should have been 4, in which case we'll get the 8. So hopefully that makes sense. So basically you're going to do a BFS on this tree to get the target nodes from this tree. You're going to do a BFS on this tree to get the target nodes from this tree. You're going to use k here, k minus 1 here, get the biggest value from here, and just add it to all of these. And that's basically the problem. So yeah, if we look at example 2, I guess we can do this really quick. So k here is 1, which means in this tree we're going to use 1. So here is 5, here is 2, 2, 2, 2. And then all of these, now you want to use k equals 0, so you can only go to itself. So 1, 1, 1, 1. That's why they said connect node with any tree in the second tree, because it doesn't matter. Like all of these have a value of 1. So this will go to 6, 3, 3, 3, 3. And you can see that's in the answer. All right, so let's take a look at the code. And yeah, there's like kind of a bunch of parts you have to do. So kind of show you kind of like a clean way to do it. I wrote some stuff, I wrote part of it, and then I GPT refactored. I'd recommend doing that to like figure out how to write things cleaner. And you can see it took me a while because there's a lot of code I had to clean up. Okay, so first we get n and m, which is like the number of nodes. And because if it's a tree, in a tree, you can see like for this picture, in a tree with no cycles, for n nodes, you'll have n minus 1 edges. That's always the case. So here you have 5 nodes, you have 4 edges. So you can get n and m, and then that's how you know like all the nodes. So we're going to build these trees, and we're going to have a result, and we're going to have this like max from the second part. And so first we can calculate, so we can also use a build tree function to build the graph. So it's basically going to be the same thing. So you just make a build tree function to build the graph because it's going to be duplicate code. Then yeah, you're going to make, this is like max from the second tree, and you're just going to call this function, this BFS count. And so this BFS count is literally just a BFS where we pass in where we start from, the graph, and then how far we can travel. And so if we can travel 0, then we can't go anywhere. Or if it's less than 0, we'll return 0 because we can't go anywhere. And then we have the visited array. And so just basically visited. And then we have like a standard BFS. So we start at the first node, and then we just loop distance times where we get all the neighbors distance times. And then for all of those, we count up like how many nodes we visited. And so for every node, we're going to count up like how many nodes did we visit. And then we're just going to get the best there. So this part is basically part 2 in the Excalibur. And then this is part 1 in the Excalibur. So we're doing the same thing, but here we called it on k-1 because we have one less. Here we're going to call it on k. And so the result here is basically going to be whatever the BFS is on this tree 1 node plus the best value from tree 2. And then we can just return the whole thing. So yeah, this one, especially in Java, if you code it in kind of an inefficient way, it might be like 100 lines of code because there's a lot of duplication, right? You build tree 1, you build tree 2, you build this max thing for the first one, you build the max thing for the second one. There's a lot of duplication. So definitely writing like helper functions and having stuff clean is going to help out. And so as far as time and space complexity, so let's kind of think about what we're doing. So we're going, for every node in this tree, we're doing a BFS. So that's n squared. And then we're doing the same thing in the second tree. So that's m squared. And then as far as like the actual like output arrays and all that stuff is going to be n plus m, right? Because the visited array, depending on which tree, is going to be n or m. And then the number of edges in a tree is relative to the number of nodes. It's the same -1. So that's why it's n plus m for the space. Yeah, so this is definitely a good problem to practice like clean coding patterns and things like that. It's not super hard to figure out what to do. It's definitely not easy. And yeah, you could see like maybe I can submit. Yeah, I don't think it runs too fast, but it's like don't really care about that. But yeah, you can see it's kind of on the harder side of the mediums. I think mediums go anywhere from like 1500 to like 2300. So this is like on the harder side. Probably like a hard closer to that. But yeah, that's gonna be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.